All right, here we go. 8.6, solve rational equations, day 2. So what you'll notice right away makes day 2 different from day 1 is our rational equations today, they no longer take the form of proportions. It's not just a ratio equals another ratio. There's something else going on in each problem, some other term that's not part of those ratios. And you can see it again down here where here's a fraction equals a fraction, and then there's something else. So in this case, we can't just use cross multiplication to solve these problems. Instead, we're going to use a strategy from earlier this week, and we're going to multiply through by the least common denominator. We're going to go ahead and clear these fractions out of here. So when I check this first problem, this has a denominator of 1 technically. I'm not too concerned about that. This denominator of x minus 5, that's a factor of x minus 5. And then this one has a factor of x. And so I need that as well. I'll put that in front because that's a more traditional way we'd write it. So now I'm going to multiply every one of these terms, that's all 3 of these, by the common denominator of x times x minus 5. So I'm going to put an x times x minus 5 right over here. Now again, technically I could do this once and distribute it. I like showing it each time. I just think it helps me see what's canceling and what isn't. Because I can actually cross stuff out now and not have to worry about using it again later. So in this first step, nothing cancels, in fact. It's x times x minus 5 times by 1. So that just stays the same. But it is x times x minus 5 there. Now in this second piece, the x minus 5s cancel. So it's minus x times 8, or minus 8x would be another way to say that. There's my equal sign in the middle. On this side, the x's cancel, and we're left with 3 times x minus 5. And we can write that out using parentheses like that. So now from here, we're solving this equation moving forward. I'm going to start on the left by distributing x times x for x squared minus 5x. I'm going to leave the minus 8x as it is for right now. Then go ahead, distribute on the right, and get 3x minus 15. Now I'm going to group my like terms together, and that would mean on the left side here, I could do negative 5 minus 8 for negative 13x. And now I want to get all my terms on the same side, solve a quadratic. So I'm going to move everything to the left where my x squared term is. That means doing a minus 3x as well as a plus 15. And again, you can see how I lined that up so that the x squared is right there. The negative 13 minus 3x is lined up. It goes together to make minus 16x. And then the plus 15 had nothing above it. It just stays the same. While on the other side, everything canceled. There's nothing there. It's a 0. Now we're factoring this trinomial, a product of binomials. And I'm looking for things that multiply to positive 15. They must be the same. And then they add up to negative 16. So it turns out you might have negative 1 and negative 15 both work. That's x, you know what, I'm going to run out of room, I'm going to go over here to finish that. That's x minus 1 could equal 0, or x minus 15 could equal 0. That's x equals 1 or x equals 15. And when we check to see if any of these are extraneous, when 1 goes in, the original problem, we have no problems there, no zeros in the denominator. When 15 goes in, 15 minus 5 or 15 right there, no zeros in the denominator. So both of these answers are good answers this time. Moving on to number 2, I'm looking at all those different denominators. I even see that that one can be factored. So first thing I'm going to note is that x squared minus 9 is the same as x plus 3 times x minus 3. And doing that proves to be really helpful because now when I see that this needs a factor of x minus 3, I see I already have one. And here I need one of each. That's exactly what I have when I factored it. And here I just need an x plus 3. I already have one. So this is the common denominator. I'm going to write it in my factored form because it'll be easier to cancel. So I'm going to do x plus 3 times x minus 3. Remember, I'm just kind of squeezing that in each time. X plus 3 times x minus 3. So one at a time now. On this one, the x minus 3's cancel each other. I just have 6 times x plus 3, use parentheses for the distributive property, equals. This one, everything cancels. They don't quite look the same right now, but we know they are from earlier. So the x plus 3 times x minus 3, the x squared minus 9, they all cancel. We just have 8x squared there. And then over here, it's the x plus 3's that cancel. So I have minus 4x times by x minus 3. And that's that step. So now we're looking to distribute. That's 6x plus 18. And this one is 8x squared, going to stay the same for right now. I'm distributing a negative 4x, so that's negative 4x squared. And again, sticking with that negative times negative makes positive 12x. Now I'd like to combine some like terms. The left side looks good for now. The right side, those x squareds can go together. 8x squared minus 4x squared is 4x squared. Then there's a plus 12x. Move everything to the same side. I'm going to do a minus 6x and a minus 18 here. So we end up with 0 equals 4x squared, and then 12 minus 6 is plus 6x, and then there's that minus 18 is still there. All even numbers, so I notice I can divide everywhere by 2. That's going to make this a lot easier to factor. The 0 is still a 0, but now I have 2x squared plus 3x minus 9, and then that can be factored. 2x times x, and then if I put a minus 3 right here, as well as a plus 3 right there, you'll see the minus 3 times the plus 3 makes that minus 9, while on the outside right here there's a positive 6x, on the inside right there is a negative 3x, and positive 6 minus 3 gives us that positive 3 there. So now each of these can be set equal to 0, and you're going to get some possibilities like, well, maybe x equals 3 halves, or x equals negative 3. That was just an add 3, then divide by 2 on both sides, or over here a minus 3 on both sides. Now when I check these, I want to make sure, again, no extraneous solutions. So when 3 halves goes in, I'm just checking, would that make this denominator become a 0? And 3 halves minus 3, that does not become 0. 3 halves squared is 9 fourths. 9 fourths minus 9, that does not become a 0. And 3 halves plus 3, that would only get bigger. So again, does not become a 0. X is 3 halves is looking good. Check that negative 3, and you'll notice that when it checks out here all right, there's later examples where it doesn't, that a negative 3 right there would create a denominator of 0, and of course that means it's an extraneous solution. So I'm going to go ahead and get rid of the x equals negative 3. Just one answer this time of x equals 3 halves. And finally, one last problem for today. So example 3 here. So now the beginning parts should all seem very familiar. And that's check your denominators. There's a factor of x minus 2, a factor of 1. We don't need that. In fact, a factor of x minus 2, I already have it. So the common denominator is just x minus 2. And that's what I'm going to multiply by everywhere, is times by x minus 2. So in the first term, it all cancels. There's just a 5x right there. There's the equal sign. Now that's 7 times x minus 2. I'll use parentheses for that. And over here, the x minus 2 cancels. It's just a plus 10. So this looks a little simpler than some of the last couple ones we've done. 5x waits for later. Distributive property here makes 7x minus 14. And then don't forget there's a plus 10 there. Combine some like terms, so we get negative 14 plus 10 is negative 4. And now I'm just solving an equation. It's not even a quadratic. Variables on both sides. So I see that I have a constant on the right. I'm going to move my variable to the left. Minus 7x minus 7x. That gives me negative 2x equals negative 4. And then a divide by negative 2 on each side. So just one answer this time. X is 2. Then I do want to check and just make sure that I didn't have an extraneous solution here. So I go ahead and check when x is 2. And back in the original problem, sure enough, right away, 2 minus 2 would make a 0 in the denominator. This is an extraneous solution. So if the one and only answer we found turned out to be extraneous, it doesn't actually work. And the final answer for this problem is there is no solution. Alright, so that's it for today. Go ahead and work on the few practice problems that are assigned for today, and thank you very much.